Hey, it's Alex Williams, the New Stack here for a demo with Nitin Shapir of Epsagon. Hello, Nitin. How are you?
I'm good, Alex. How are you?
Great. We're going to take some time today to go through Epsagon and discuss Epsagon in the context of the overall market and what we are seeing out in the real world. Nitin, why don't we just get started?
Yes, for sure. Thanks, Alex. So, as a quick introduction, I'm going to talk a little bit about what we are seeing today in the market. And so, the first thing is that organizations want to build software faster because that has a very direct impact on their business. In order to do that, one of the things that they are doing is using microservices patterns, which enable them to develop faster with better scalability and efficiency. So they use technologies like Docker, containers, Kubernetes, and so on. The second thing is utilizing the cloud, of course, because in the cloud, you are not limited by any kind of thing pretty much. And you can just focus much more on your business logic instead of worrying about managing infrastructure. So these two things are combined, and this leads us to the steps that companies are taking in the adoption of the cloud. So the first part will be kind of a lift and shift. So taking whatever you have on the data center and putting it on a virtual machine. But then obviously you don't want to write a database or even manage a database. So you can use an API for that. And for everything else that you need, you have many, many APIs, both in the cloud provider domain and in the internet, to save you the trouble of writing code that's already there. So APIs is a very important part. And the last part, which is also the newest part, is how do you actually run your code without managing any infrastructure? So services such as AWS Lambda or AWS Fargate or the Azure Container Service will allow you to bring your code either as a code or as a container and run it without managing any infrastructure. And that's kind of the holy grail because you don't have to worry anymore about what's going on except for your code. And then you can really develop much, much faster. So while this adoption is happening, we are seeing what we call a modern application in the cloud. So how does it look like? First of all, it's built on the cloud. So using many, many types of services and APIs. And the result is a very distributed application that is comprised of different services, both containers, both Lambda functions, some are running on a virtual machine, and they all communicate with many APIs and with one another in various ways. In the past, communication would usually be direct, process-to-process communication, but now you have many things like asynchronous events, message queues, triggers that are built in the cloud provider's domain, like the SNS over there. And the number of events is very high. The types of events is very high. So it's very difficult to understand what's going on. And on top of that, the host may not be accessible anymore in the example of Lambda or Fargate. So how are you going to install any kind of agent going to help you?
Just for people's own clarification, what is the distinction that you see between Lambda and Fargate?
So Lambda is a service that is kind of a new service. So you have to write your code in a certain way, ship it into the Lambda in the correct format, and connect it to all the triggers and AWS events that are part of the ecosystem of Lambda. Where Fargate, you can bring your container, your Docker container that you already have. It may be running today on premise. It may be running today on a virtual machine on an EC2, and you can put it in Fargate. So the main difference is that you don't have to write things especially for that, like with Lambda, that it's a kind of a new service. You can bring containers that you already have and you are already familiar with, and you are used to work this way.
Okay, great.
So overall, if you look at the monitoring and the troubleshooting landscape, so you can divide it into two types of tools. So the logs would be used mainly by engineers to troubleshoot problems. However, again, logs are still the common way, while distributed applications are getting more and more common. And as the applications become more distributed, basically the logs are not going to be providing a lot of information because the logs don't have the context of the application. And the traditional application performance monitoring tools are still very focused on monolithic applications and very focused on agents as well. So you end up with kind of a mix and match between tools that on the one hand, you have the logs that are just not providing a lot of context when it comes to distributed applications. And then you get the tracing and the monitoring that are traditionally used by IT operations, but today both DevOps and engineering need them. And there is no correlation between the tools. So the result is that the developers today, that companies really care about their velocity and their efficiency, are now spending so much time coding observability into their systems, and that's a major drawback into the developer velocity. So Epsagon is aiming to solve these problems by providing an automated solution that is also agentless, so it can run anywhere. It's focused on automated distributed tracing, and it's built for modern cloud applications. So before I'm going into the demo, just to explain how Epsagon works. So Epsagon is based on automated code instrumentation that is all in the code level. So it can run anywhere from Lambda to Docker container to Fargate to Kubernetes and so on. We support various types of languages, and we have ways to add the library in a way that is very, very simple. So it takes just a few minutes to set up. There is no manual code changes involved, only adding one line of the Epsagon library or using one of our plugins to have it there automatically. And then the customer eventually gets a view of all their production applications automatically traced with a unified view for the tracing and the logging. So that's something very revolutionary because, again, traditionally, those would be separate tools. So now I can go into the demo to show some examples.
Perhaps you could just briefly talk about the technology architecture behind Epsagon to give us some perspective on your distributed tracing model.
Yes, so Epsagon uses, again, code instrumentation to extract events from the running time of the code. Then they are being sent to the Epsagon backend using what we call trace collector that are deployed in all the cloud regions. So the impact on performance is very, very low, just a few milliseconds. And then Epsagon backend digests those events in very high scale and connects them together to create those traces automatically using different identifiers. So we have ways to correlate events based on existing identifiers that are already there, or to add identifiers of our own to be able to help us track them through the system. The point is that we rely on the fact that companies use standard SDKs and standard APIs today. So it is definitely possible to do that automatically without requiring the user to code a lot of stuff manually. However, we are open tracing compatible, so customers can use that if they need to extend beyond Epsagon's capabilities. Today, our customers get almost 100% coverage for whatever services they use just by adding Epsagon in a matter of minutes. So that's a huge benefit to them because they don't have to spend any time training, maintaining, or implementing any kind of manual tracing into their code.
Great.
All right. So I'm jumping straight to the Epsagon demo. So what we have here is our public demo environment that is accessible to anyone without any signups. And I jumped directly to the architecture map, which is Epsagon's visualization of the production application. Here you can see an application that is comprised of both Java services, Spring Boot framework, and just a standard Java service, and the Lambda function, Kafka, queue in the middle, DynamoDB, S3 trigger. So really a mix of stuff. And Epsagon is included in those three services. So just adding one line and that's it. And what you have here is an auto discovery of the production application, and it is dynamic, meaning that as the company or the team is building new services and adding more things, it will be updated. So the team always knows what they have now in production, which gives them a lot of confidence to build new stuff instead of worrying about, oh, what do I have now in production? I'm not even sure it matches what I have on the design, and so on. So this is a very good way to give you confidence in your production application and also get performance metrics of the different services. And now here you can see the various applications that you have. So this is another application comprised with Lambda functions and many services, including API gateways, Auth0, Twilio, Kinesis. And again, everything is automatically traced without any manual code changes. So that would be a good way to get a sense of how is my production looking like right now. Now, one of the things Epsagon provides is monitoring. So the issues manager is tracking all the issues in the application and notifies the user of problems. So it can be things like errors, it can be timeouts or out of memories in functions, and it can be things that are going to be errors soon. So this function is close to the timeout limit. So all of these things are presented in a very convenient way to the customer or the user to see what problems they have. Now, in terms of troubleshooting, once you see a problem like this, you want to understand what is the impact. So if I click on the arrow, I'm going to go into a view called trace search, which allows us to search across all the payloads and the data in Epsagon's database, which is very unique because traditionally this data is not saved anywhere. But here you get a search for this specific error that happened in one of the functions that I have here. And then I can take a look at one of the functions. So by clicking on the problem, I get directly to Epsagon's distributed tracing view, which allows me to see all the information right away. So this function had some exception. Now, if I just had the logs, which I can get in Epsagon directly from CloudWatch, I can see the log of the function, and I can see that the zero division error indeed happened here, but I don't really know why it happened, because that's the problem with distributed systems. Many events are connected together and eventually lead to the result. Looking again at the graph, I can...
do you find how do you find that as a challenge in the customer journey?
So usually the customers, when they have some solution in place, it's going to be mainly based on logs. And then when they go into the log, like I showed before, they're going to say, okay, I have this information. Sometimes they don't even have any information in the log. But even assuming they have the information in the log, it's going to tell them what happened in this particular service. But in this case, there are 2 services involved, and sometimes there are 10 services involved. So not all the information is presented to them in the log. And as you can see here, looking at the log is really not going to tell us much, because all I can see is that there was some exception, zero division, but I don't know why this number was actually 0. There is some logic behind it that is not inside this function. It's in another function, that there is no correlation between the 2 functions just by looking at the logs.
Okay.
So Epsagon actually does this correlation for the user. So just visually, we can see that there was an SNS involved, another Lambda function that came before that, an authentication API that failed, so it's marked on red color, and an API gateway that started the whole process. So with Epsagon, I can see that this is the exception. This is the log. I already have information about the SNS. So if I click on the SNS, I can see the actual message that was transmitted to the Lambda. This is not part of the log. This is traced automatically by Epsagon, and I can see that the user was not authorized, which is probably the problem. And if I go to this function, I can get the log of the function right away. So it's not just any log, it's the specific log that I'm looking for. And it can tell me that indeed the user was unauthorized, as you can see in this example. So troubleshooting was very easy. And the Auth0 API can also show me that the 401 status code and the unauthorized response proves that the problem was that the first function transmitted a user that is unauthorized. Another example would be using the search to troubleshoot other types of problems. So let's say I want to know what's going on in my Stripe API calls. I can just type in Stripe and I get all the API calls in Stripe, and jumping into one of them is going to take me to the other application that I showed before, which is comprised of container services. So here you can see the Spring Boot application, which starts by receiving the HTTP request. And I get all the information about the HTTP body and the header right away. I can search this information because it's indexed. And I can get information about the container service here. So this one is actually running on a Fargate, and this one is running on an EC2. But for Epsagon, it doesn't matter because it can work across any workload. And even the Kafka message here, you can easily see what's going on inside of there. You can search this information. And the timeline view provides you a good sense of where you spend your time. So, of course, in this example, the Stripe API is a very significant time duration because it took 1 second compared to about 30 milliseconds or 4 milliseconds in the other services. So that's a very neat way to look for problems. I can just look for a string Netflix that was in one of the payloads and find the event right away, and again, jump and troubleshoot the issue right away.
So you have it all indexed. What is this search you build underneath?
So our database is based on Elasticsearch with our own capabilities that we enriched it to match this type of distributed tracing data. So we are not a log aggregation tool. We are not telling our users send our logs to us. We are telling them use Epsagon to get the best understanding of your distributed application, and logs are just part of the story. But we are also creating payloads that were not there before, like the DynamoDB items that are traced here, or the S3 file names that are also being part of the trace. So you can search all this data as well. So the logs are becoming let's say, just a small part of the story.
Mm-hmm.
So the trace search is very powerful. You can also configure notifications into multiple services such as Slack, PagerDuty, VictorOps, Opsgenie, and more. You can do that based on an application, which is a group of services, or based on a specific service. We have a Slack application. We have a spatial integration with AWS Lambda. So just by deploying a CloudFormation template, we are able to gather a lot of information about all the functions in multiple AWS accounts. And then you can filter which functions you're interested in. You can look for the function that you want to look at, and then get errors, timeouts, out of memory issues, even the estimated monthly cost for each function. And it's very easy to group the functions together as an application. And then you can set it, and then you can filter across the application in various views of Epsagon. If you have Lambda functions, you can also use one of our auto instrumentation technologies. So the instrument button here that is enabled for users is going to add the Epsagon layer directly into the AWS account of the user without any code changes, and it's going to instrument the function for them. And then, for example, when you want to troubleshoot a function, you can also use this function view to take a look about what's going on in the function in terms of invocations, errors, memory, and duration, and then get a table of each and every one of the invocations here. So just by looking at an invocation, I can see that this one failed. I can get the log directly from CloudWatch. So we don't store these logs. We get them on demand from CloudWatch. And of course, click on an invocation to get to the distributed tracing view, which is very, very helpful to root cause complex problems. You can also search across the CloudWatch logs directly to search invocations that match.
How chaotic is it getting for customers these days? And where does the Epsagon solution really seem to fit well?
So when customers are building services and applications on the cloud, they have much less constraints. They can do almost everything, and they can do it very quickly. So they just add more and more services. We have customers that are adding dozens of new services every week. So just imagine there is a team of hundreds of engineers and DevOps people, and they don't even remember what the design was, because there is no design anymore. It's just ever changing. It's evolving every day. So it can actually be very chaotic if you get to a point when we have dozens of services, not to mention hundreds of thousands. Just the fact that you want to build quickly is going to be a big challenge, because you can't build if you don't know what you currently have. So the chaos comes both in the building side and on the troubleshooting side. So when problems happen, companies now or teams spend hours or even days to solve problems like those that I showed you before, because they have billions of invocations or billions of events coming into their systems every month. And when something happens, it has to be correlated with many, many other events that nobody's going to correlate for them. So the chaos is really just growing. So having a solution that's going to do this automatically for you can just give you a peace of mind and enable you to build faster and to know that you can troubleshoot every issue in a matter of minutes instead of having a big crisis every time something happens.
And that's something you really can't do with traditional APM environments and solutions. You can't really be able to have that level of corollary without configuring it manually. Isn't that true?
Yeah, so traditional APMs work very well for monolithic applications. Where everything is in one place, the instrumentation technologies, the agent-based technologies did a pretty good job. But when there is another layer, which is the logical layer of the application that involves data going around services from side to side, just having the context of a single service is not going to do the job. And then organizations try to enrich whatever they have with a lot of manual work that eventually is going to take 30 to 50% of their developing time, and the result is not going to be that good either. So the automation and the distributed tracing are key of what makes Epsagon the best solution for what we call modern cloud applications.
Great.
Yeah, so to get started with Epsagon, it's actually very simple. You can just sign up and you can get those kind of diagrams in a matter of minutes. This is not like an exaggeration. It really takes less than 5 minutes to set up. We also have a weekly live demo that you can sign up to on our website. So we actually go through the product, we answer questions. The next one is going on tomorrow, so you can just sign up on the website. And our team is always available.
Tell us about I just have a few questions. Tell us about the security that you have built into the overall Epsagon environment.
Sure. So Epsagon is, first of all, we are SOC 2 certified and ISO 27001 certified, and we are going to be HIPAA compliant next month. Our engineering team comes actually from a security background, so we take security very seriously. We are built on top of the cloud as well, so we use the most standard technologies. Everything is encrypted. Everything is, authentication and security is all used by the tier one technologies that companies use today. We don't try to write something better. That's what's already out there. So we use Auth0 for authentication, for example, and we use encrypted databases. We have very, very strong practices into security and authorization of people to the data. And the user can actually choose what data he wants to send to Epsagon. So in our instrumentation library, there is an option to send just the metadata. So when you have the library in your code, you can say, oh, I don't want to send any data. I just want to send metadata. And then no private information is going to be stored at Epsagon.
Great. And in terms of the performance you promise, is there any other performance issues that customers should be aware of when they're using Epsagon? And for the overall technology with the added addition of the code, I mean, it seems like it's pretty minimal in terms of, just in terms of what it adds to their overall code base.
Yeah, so honestly, there is nothing else to worry about. Everything that Epsagon does can be seen in our open source library, so it's very easy to see what we do. We just collect all sorts of types of information from the code, and then we send it just one time every time the code is executed. To put this number to the minimal value. So just a few milliseconds, and honestly, none of our customers never had any issue with that. The product is a SaaS product, so there is nothing you have to install in your environment. You just need to put the Epsagon instrumentation, and that's it. And then everything is going on through the dashboard that I just showed. So really, it's just that, yeah.
Great. Well, this has been real helpful. I really appreciate your time, and we look forward to learning more. Is there anything else you'd like to add before we go?
No, I mean, we are very available, so we are happy to get much deeper into the product and to do a technical demo for people that are interested in that. Working already with dozens of companies across the US and Europe. So let us know, what do you think? Yeah,
I think, one of the last things I just want to say is you do a pretty good job with your documentation on your site, and the blog is updated, and you do lots of demos for people on AWS, on showing how the Epsagon technology works. I guess my last question is, what are some of the most common use cases you're seeing that with customers, just in conclusion?
So we see a lot of adoption of these modern applications across internet companies. So software companies are built on the cloud. They started in the cloud almost from day one, and they utilize them very heavily. We see a lot in the e-commerce industry. So web applications, mobile applications. These companies want to become as modern as quickly as they can. And they tend to go into the cloud and into microservices and serverless to enhance their development time, the go-to-market time. And also lately in the financial industry as well. So they do it sometimes to save costs and also to just become more and more modern.
Excellent. I've been joined for this demo with Nitzan Shapira, the CEO and co-founder of Epsagon. Nitzan, thank you very much for your time.
Thanks, Alex.